So here I'm going to test and demonstrate Dart's ability to navigate this rectangular obstacle course with and without feedback from the onboard IMU. So first we'll just be relying entirely on the encoders to see if we can navigate the marked rectangle. So there's no encoder feedback. So despite a 90-degree command to turn left, Dart really only turned about 70 degrees, and that error is compounding as it has to make further left turns. So as we can see, it's really nowhere near the starting point marked by the X. The trajectory plot will give more insight into just how far off Dart's trajectory became. The end of the yellow arrow is where Dart's final position is relative to the purple arrow, which was its starting position. Ideally, it's returned to the starting position marked by the purple dot at the far right of the plot. So now, instead of just relying on encoder feedback, we're going to see how Dart navigates this small rectangular obstacle using IMU feedback to determine its absolute orientation in yaw. So the linear method of translational control remains the same. As you can see, that cumulative error at the turn isn't nearly as high as it originally was using only encoder feedback. And it keeps actuating until it really reaches that absolute orientation change that's desired. So it really navigates back to its starting position with minimal error, period. Now if we look at the change in the plotted trajectory, Dart's first movement is the purple arrow at the lower right. And then there's only minimal sway in its position as it moves off of its track. It's moving about 3 feet, so just in the first translation along the purple line, so just being under a meter checks out. And yeah, these results are much better than just using the encoder feedback, so the more sensors, the merrier.